Okay, here's the second review for you. Given that the sine, and we're on that doesn't really mean much, the second part. Find the cosine double angle. So we're looking for a double angle formula for cosine. Okay, but first we have to draw our triangle with a sine of 8 over 17. Okay, so that's opposite over hypotenuse, which means our other side is 15. Okay, Pythagorean theorem. So cosine, there's a formula for that. That would be the cosine squared of the angle minus the sine squared of the angle, right? There's 3 of them according to your chart, but this is the one that I want to use. So this is the one I'm going to use. So we go to our triangle. The cosine is 15 over 17. So 15 over 17 squared minus the sine is 8 over 17. We're squaring that also. Okay, so 15 squared is 225. 17 squared, 289. 64 over 289. Okay, and now we just have to subtract 225 minus 64 is 161 over 289. Okay, so we're just using that formula for our cosine of a double angle. And we're getting our values from the triangle, not from our unit circle. Okay, let's move on to number 7. The sine is 1/4 and the tangent is positive. Okay, so they're telling us this is our quadrant. This is saying that the tan is positive, which happens in the first quadrant and the third quadrant. But the sine is also positive, so this is basically a first quadrant triangle with a sine of 1/4. So according to Pythagoras, our missing side is going to be root 15, because that's what 16 minus 1 is. So the tan of 2 theta, well, there's a formula for that. That is 1 minus the cosine over the sine, right? There are many, many formulas, but we're going to use 1 minus cosine over sine. So we got to replace the cosine from our triangle. The cosine is root 15 over 4. No, wait a second. That's the wrong formula to begin with. Tan of 2 theta? Yeah, that's what you're thinking. Sorry, let me pause and erase all this. So sorry. This is our double angle formula. I was looking at the wrong chart. My wrong thing. So all I need to do is replace my tangent. So let's do that. I'm going to erase tan and write it in with its ratio, which is opposite side, which is 1 over hypotenuse. The tangent is 1 over root 15. Okay, which we can simplify to root 15 over 15. I think that might help us out there if we do that. Sorry, that's kind of sloppy, but let's go on. So 2 times this is 2 root 15 over 15. That's my numerator. 1 minus root 15 squared is normal 15, and 15 squared is 225. Okay, so now we need to change our 1, right? Our 1 needs to change to be fancy. In this case, it's 225 over 225, so that I can perform this subtraction. So 2 root 15 over 15 divided by 210 over 225. Okay, I'm pretty sure this is reducible. So what happens when we divide it by 5? In fact, they're divisible by 15. So when I divide them by 15, I get 2 roots of 15 over 15 divided by, this becomes 14 over 15. Oh, that works out nicely, because my denominators of 15 cancel. I can reduce my 2 over 14 and get root 15 over 7. Well, that's a very nice answer. There you go. So there's our tangent double angle formula working right there. Okay, here on number 8, you need to recognize that this is already in the formula form. The tan of 115 minus the tan of 70 means that our A angle for our formula is 115 and our B angle for our formula is 70. So we can take the formula part and transform it back into the non-formula part with a minus on top. That means it's a minus tan formula. This is a tan of A minus B formula. So we're going to go back to its basics, the tangent of 115 minus 70. Okay, well, I know how to do subtraction. 115 minus 70, that's 45. Oh, and that is a unit circle angle. The tangent of 45 is positive 1. Okay, remember, this comes from your unit circle. So these type of problems are working backwards from your formula to the base, right? How we're starting, the sum and difference. So when you see these ones on your test, don't freak out. Just write down which is your A and which is your B. So for number 9, the A is your 120, and the B angle is 30. So hopefully we recognize this formula as being a cosine of an A plus B formula, right? Cosine, cosine, minus sine, sine. That is a cosine of A plus B formula, with A value of 120 and a B value of 30. So let's go ahead and write those in there. We will replace your A with 120, and we'll replace B with 30. So I know how to add 120 plus 30 is 150. And now I can go to my unit circle, once again to my unit circle, because 150 is a unit circle angle, and the cosine is negative root 3 over 2. So with these problems, they're giving you the formula with your angles already plugged in. You need to recognize which formula it is and simplify that, right? Turn it back into the left side of your formula as opposed to the right side of your formula. Okay, so back at number 10, it says the sine is 1 over 4, and it tells you what quadrant we are in. Okay, remember this here, this type of notation is telling you what quadrant. And it happens to be the first quadrant, because that's between 0 and pi over 2. So we draw our triangle in the first quadrant, and sine is the opposite side, which is 1 over the hypotenuse 4. Okay, and then Pythagoras will say 4 squared minus 1 squared. Our x value is the square root of 15. Okay, and we find that by doing Pythagoras with 4 as your hypotenuse and 1 as your side. Okay, and then it says find the cosine of the half angle. So let's think about the formula for cosine half angle. It's in the first quadrant, so it's positive 1 plus the cosine of the given angle divided by 2. Okay, so this is the formula from your formula chart. So we have to do one replacement for here, and that's to replace the cosine of the angle with its fraction from our triangle. Remember, cosine is the adjacent side, which is root 15, divided by your hypotenuse, which is 4. So we're going to squish that way up here, root 15 divided by 4. That is our cosine fraction, or your cosine ratio from your triangle of opposite over hypotenuse. Now, looking at our numerator, we have to add a 1 to our fraction. So I need to change my 1 to match my fraction. So my 1 becomes 4 divided by 4. That way I can add my fraction on top to something else. I can only add a fraction to another fraction. Okay, so let's do that fractional addition. Remember, when I'm adding fractions, I only add their numerators. So 4 plus root 15 divided by 4. That is my new numerator when I add those two fractions together, all divided by 2. Remember, 2 is still underneath the square root also. Okay, so I'm adding my numerator together, 4 over 4 plus root 15 over 4. Okay, so now rather than dividing by 2, I'm going to instead multiply by its reciprocal, which we have done many, many times during this unit. We multiply by reciprocals all the time. So 4 plus root 15 over 4 times 1/2, right? Not dividing by 2, but rather multiplying by 1/2. Which gives me a final answer of 4 plus root 15, because multiplying by 1 doesn't change anything, and 4 times 2 is 8. And since none of these are perfect at all, right, there's no perfect square, 8 is not a perfect square, I am not going to split this into top and bottom. We're going to leave our answer like that, just like that. Okay, back to 11. Our last one is number 11. Given the tangent ratio and the fact that we're in the what quadrant here between pi and 3 pi over 2? That's the third quadrant. So we're going to draw our triangle with this orientation, the right angle to the left and our triangle going down. So tan is y over x, so 12 in the y and 5 in the x. But you need to know, in the third quadrant, the x and the y are both negative. Okay? Our tangent is given to us as a positive ratio. Well, a negative over a negative sure is a positive. In the third quadrant, both your x and your y are negative. Important to know. So then we do the Pythagorean theorem, and we get a hypotenuse of 13. Okay, now to find the sine formula, the sine of our half angle is, let's talk about what quadrant we're in. We're in the third quadrant, so sine is negative in the third quadrant. So we're going to put a negative outside of our radical. The sine formula is 1 minus the cosine of the angle divided by 2. So let's come in here and replace the cosine. Okay, we know what that ratio is. The cosine is the adjacent side over the hypotenuse. So negative 5 over 13 is the ratio for our cosine. Okay, with a negative, right? It's negative 5 over 13. But algebra says a minus becomes a plus. And I can replace my 1 with a fancy one known as 13 over 13. Because it has to match my denominator of 5/13. Okay, so those things have to match up when we're doing fractional addition and subtraction. So simplifying gives us a negative on the outside. 13 plus 5 is 18 over 13, all divided by 2. Okay, 18 over 13, all divided by 2. So once again, I'm dividing by 2. No, I'm not. I'm going to multiply by 1/2. So negative 18 over 13 times 1/2. We're multiplying by the reciprocal. So when I multiply 18 by 1/2, I can simplify this to 9 over 1, right? 18 divided by 2 is 9. So this becomes the negative square root of 9 over 13. Which, hopefully we know, 9 is in fact a perfect root. So it's going to behoove us to split this into the square root of the top and the square root of the bottom separately. Okay, so we split it into top and bottom because this 9 has a perfect root. Well, that's 3, and root 13 does not. So this would be okay. but you could make it better by rationalizing. In other words, we'll bring the radical 13 to the top and make it a normal 13 on the bottom. And that would be your best final answer. -3 root 13 divided by 3. Okay, so there's a formula for every single problem. Sometimes you're allowed to use your unit circle if we have an angle, and if we don't have an angle, then you have to make triangles and find your ratios from those triangles. Okay, good luck, good brains, and bring your yellow formula sheet with you.